It works for geometry and geography. And it's the classic problem of you have a location and you want to find things of a certain sort, of a certain kind. Like, for example, all the fast food restaurants within 1,000 meters of here. You would use this function called StDwithin. And what that does is it takes two geometries. They could be anything. In this case, I have both points, but they could be polygons. And it would be the closest distance on the surfaces of those geometries. And it would pull them all together, and then you can order by anything that you want. So in this case, we got 7 fast food places that are within 1,000 meters of here. This next one is something that's new in PostGIS 2.2. It's called the Subdivide function, and it's a set returning function. And what it'll do is, for any geometry you give it, it'll chop it into smaller bits. And this is useful for performance reasons. For example, if you have a huge state, it's often useful to chop that into smaller polygons. So when you do intersects, the number of points that it has to be dealt with is a lot fewer. So here's an example where I take 4 states. So I have 4 rows. And then I pass it through the subdivide function. And the second argument to the subdivide is the max number of points you want each geometry, each output geometry to have. So by saying 1,000, it's going to divide it such that no piece has more than 1,000 points in it. So you end up getting 4 states converted to 186 polygons instead of 4 polygons. Okay, this one's a new trick in PostGIS 2.3, and I usually use it for modeling purposes mostly, but I guess other people might have other uses for it. And it's basically a random generator of points. And if you give it a polygon or a multi-polygon, it will basically fill that polygon with points for as many points as you want. So in this case, if I say I want to fill North Carolina with 1,000 points, I will end up with a new geometry that's a multi-point composed of 1,000 points. You can see it kind of forms the surface of North Carolina. Okay, these are 2 new functions in PostGIS 2.3, and they're clustering functions. A common use case is, for example, if you have lots of parcels of land and you want to package them together into units that are close. So you want to package 2 lots that are right next to each other as a unit to sell, or for other reasons, like 2 things that really should be connected are not connected. You can use these functions. The first one is what's called a KMeans, and it basically computes the centroid of each geometry, and then it buckets the geometries based on their proximity, based on their centroid proximity. So the first argument is the geometries that you want to put through. It's a window function, so it requires this over clause, and you can use any features of window functions like partitioning and order by to control how you group things. So in this case, this is like the very simplest form of it. It's basically saying that for the set of data that I'm going to check, in this case, I'm only checking things within 500 feet, because this is a North Carolina state plane feet projection. It's going to return a number between 0 and 4 for all the records. And the bucket means that they're closest to each other. So for example, you see these 2 buildings have 0 because they're adjacent to each other, and these ones have number 3 because, again, they're close. And these ones are kind of close, so they get the same number. Another function in 2.3 that does the same thing but does it a little differently is the ST cluster DB scan. And the DB scan part doesn't stand for DB. It doesn't stand for database or anything of that sort. It stands for density-based something noise. And the idea behind that is the first argument is geometry. The second argument is a distance measure, which is always in the spatial reference system. So in this case, I'm saying that I want all geometries that have zero distance between them. So basically, they intersect to be grouped together in a unit. And this last argument is kind of hard to explain. It's basically how many within that unit have to satisfy the minimum distance requirement. So in this case, I have 0. So you notice the difference between this function and the KMeans is that things that are not connected at all, they get a different bucket. So these ones before, some of them were connected and some of them weren't. And this set was broken into 2. So these 2 that connect have the same bucket number, and these ones have the same bucket number. And so with this function, you can then later group by and union things together. Okay, coming in 9.6 with PostGIS 2.3, this is something that people have asked for quite a while, is being able to do being able to take advantage of parallelization in queries. And in 2.3, we're going to have some of that with the ST-intersect functions, and there are a couple of other functions like area and the other geoprocessing functions that are going to be able to take advantage of this. Unfortunately, some aggregates, like the big aggregates like union aggregate, are not going to be able to take advantage of parallelization. So depending on how your query is written, it could take advantage of, it can use multiple backends instead of a single backend for processing a single query. So in the cases where it can be used, you'll probably find the performance is doubled or quadrupled, depending on how many cores you're using. Okay, this one's an old favorite, and if you do a lot of flight management, you'll probably appreciate this one. In 2.1, there was ST segmentize was introduced for geography, and the nice thing about segmentizing in geography is, first of all, you can specify your segmentization units in meters. So basically, the segmentize takes a geometry of any sort, and it adds nodes to it. So, for example, if you have a line string that just contains 2 points, and you segmentize it, if you segmentize it in geometry space, if you're using longitude, latitude coordinates, and you segmentize it in geometry space, you'll still end up with a straight line, no matter how you segmentize it. But if you segmentize in geography, it takes into consideration the curvature of the Earth. So you get the true path that you would, for example, fly. And then you can plot that on our Cartesian map, and it would look more accurate. And so this is basically how you would use the segmentize, except without the STS text. That's just for display purposes. So you specify your geometry. You cast it to geography so that the segmentize of geography is used. And then you specify how long each segment is going to be. So in this case, I want each segment to be 10,000 meters. And in 2.2, another function was added, which is helpful with this function when used in conjunction with this function. And it's called the ST as encoded polyline, which is a common format used by Google Maps. So you can take what we just generated and then use this ST as encoded polyline, and then take this and use it directly on Google Maps, for example. And I think Leaflet supports the same thing, though I'm not absolutely sure. Okay, so in PostGIS 2.2, we added a address standardizer extension, which is commonly used with the PostGIS Tiger Geocoder, which is also another extension that's packaged with PostGIS. And it's basically a rule-based address standardizer. So you feed it, and actually there's a new one that's coming up, which Steve Woodbridge is working on. So that's the link for the new one to more deal with world data, because right now it's more catered to U.S., how things are set up in U.S. So the address standardizer takes 3 tables. It takes a lex, a gazetteer, and a rules table that dictates how, like the order in which things are specified and how to parse them. So for example, if we have a 2-line address, such as this, it will break it up into separate columns. And I used JSON just so I could convert the columns to rows for easier viewing. So the one that comes with this extension called Address Standardizer Data US, which is also packaged with PostGIS, converts the different parts into the long name. So for example, the pre-direction becomes south, and North Carolina ends up being spelled out. The Tiger Geocoder has its own set to work with the address standardizer, and it standardizes more along the way the Tiger data is set up. So it uses the short prefixes. So pre-direction becomes S, and North Carolina still stays as North Carolina. And the PostGIS Tiger Geocoder that comes with PostGIS, unfortunately, it's only useful for United States data. But you can load any of the states that you want, as many as you want, and then you'll be able to geocode by using this geocode function, which will return a geometry that you can then break it out with the XY to get the long lat if you need it broken out, or just keep it as a geometry point. And the rating, the lower the rating, the better the geocode. So this one's a perfect rating, which means it should be pretty close to where we are. The opposite of geocoding is to reverse geocode. So if you have a point and you want to get a pretty address of where that is, you would pass that into the reverse geocode function, which also comes with PostGIS Tiger Geocoder. So as long as you have the data loaded for the state, you'll be able to get an English representation of where that is, and also whatever cross streets are by it. Okay, now it's my favorite topic, is GDAL and how GDAL and PostGIS and PostGIS all work together. So in PostGIS 2.2, when we introduced PostGIS Raster, we built on top of GDAL. So a lot of the Raster functionality that's in PostGIS is made possible by the GDAL project. So that's the first thing I'll cover. And this was a product created by this guy named Pierre Rossin, who had this crazy idea that you could load raster data in the database and you could do spatial queries between geometry and raster, and the world would be wonderful. And for the most part, it is. So in order to work with raster data, you have to get it into your database. And early on in PostGIS Raster, we kind of said, people should just use NDB, which means like the raster data is stored in the database, and it's, it could be terabytes, it could be gigabytes. In 2.1, we beefed things up a little bit, so the out-of-database raster is actually pretty decent now. So there are 2 ways to, I'll call it register the raster, because the raster data stays out of the database, but you can query it as if it were in the database. You can load it with the command line tool called raster to PGSQL, which comes with PostGIS, and specify this -R, which means just register it, don't bring the data inside the database. And of course, with that said, you can't move the files. Like if you move the files, your data's no good. The other way you can do it is you can basically register all the rasters through SQL. And I like this feature because, like for example, in Windows, it's hard to recurse folders. But if you use the Windows command line the /s switch, it can recurse folders. So this requires two things. The first is in 9.3, they introduced this nifty feature called copy from program, which allows you to call out to any program that you have on your system, assuming that the PostGIS account is allowed to execute those, and then dump the results into a table. So here I create a directory listing table, and I call the windows in Linux. Of course, you'd use the Linux command, which I forget what it is, and it would basically recurse through all the folders, pick up all the TIFFs, create a record for each TIFF into this dir list table. And using that list, I can then, with this PostGIS raster function, add all the bands to a null raster. And this basically has the effect of saying, okay, here's the full path, create a raster, and bring in all the bands. And then you add the constraints. So basically, PostGIS will inspect the raster and figure out what the SRID is and check to see if all the tiles are the same size. And if they are, it will put constraints based on that. So that when you query the raster columns table, you get this nice information that, hey, all your tiles are 10,000 by 10,000 pixels. You have 3 bands, and it tells you this information that, hey, they're out of DB. They're not inside the database. And it also tells if it can detect the spatial reference system, it'll auto-detect it. So you get the 2264 without doing anything. And then, of course, it's always good to index your table, because even though the rasters are outside of the database, there is metadata that's kept in that tells like what piece of the earth that tile covers. So once you do that, you can use a function called StTile if you wanted to, which actually is not that useful for OutDB from what I have observed. So you could probably skip it. But if you had InDB, it's really useful because pulling out a 10,000 by 10,000 tile each time you do a query is kind of painful. But OutDB doesn't seem to do that, so it's probably not as necessary as if you actually stored the raster inside the database. If you have large tiles, it's usually good to have overview tables, and this is something that QGIS uses, so that when you zoom out to a raster, it shows the overview for that zoom, which is basically a lower resolution of your data. So in PostGIS 2.2, there's a new function that got introduced called this, which is called StCreate Overview. And you can feed it any raster table, and it will, and the level of the overview factor. So do you want it half, a quarter of your original? And it will create a new table, and it will name it based on the factor. So it usually starts with O and then the factor and then the original raster table name. And you notice here that this one, the OutDB part, if you look at it if you look at the raster columns, it's all false. So these are actually stored in the database. They're not stored outside. And so once you have raster data in your database, the classic thing to do, and I just do this with aerials because it's prettier to show than like a whole bunch of pixels of weather. You can pick an area, and then you can intersect that. You can intersect raster with a geometry, where geometry defines the area. So in this case, I'm defining a 500-foot area around this point. And then I can use the raster clip function, which basically clips the raster. And imagine this is actually a pretty huge raster. This is the 10,000 by 10,000 raster, and it clips it so it only has that portion of the geometry. And so you end up with a tile that looks like this, which you can then apply resize, and you can output with PNG and so forth, and JPEG, and there's a whole bunch of other formats that you can output as. And if you do it against the overviews, it's much, much faster. So for the same size tile, if I were to do this against the 10,000 by 10,000, it would take 4 seconds. But if I were to do it against the overview, it would take 1 second. So it's a great advantage to have overviews. Okay, the second part where GDAL and PostGIS Meet and PostGIS Meet is a fairly new thing, and it's something that I asked for 5 years ago. It's the ability to use the PostGIS Foreign Data Wrapper API to be able to query shape files and CSV files and all sorts of files. And that came about a year ago. And for the Windows packages, for PostGIS 2.2, it's packaged in the application stack builder, and for people who use CentOS, it's also packaged as a separate extension that you can download. And so it depends on GDAL and PostGIS, and the tilde I put here because it'll use PostGIS if it finds it installed in your database, but it doesn't rely on it to be able to install the extension and use it. And so if you want, here's the link to get the source code if you wanted to. So what's really cool about this is that this foreign data wrapper can touch so many data pieces. You can use it to query spreadsheets. You can use it to query ODBC data sources like SQL Server, Oracle, DB2. You can use it to query OpenStreetMap files, Esri shape files, CSV files, and with 9.5, it's really slick. So you install the extension in your database, and let's say you had a folder of shape files. You would just create a server that points to the folder, and in 9.5, you can use this new feature called Import Foreign Schema, and it will create a table for every single file you've got in that folder. So create a foreign table. So in this folder, I just had airports and MBI. And then you can, if you had PostGIS installed, and since it's a shapefile, it's got spatial data, you could use any of the PostGIS functions. So for example, I can convert the geometry to well-known text format. And the newest feature that's in the master of it is ability to update these data sources. So if GDAL, the driver in GDAL is writable, then you can update the file. And if your PostGIS process allows you to write into that folder. So for example, if I have a shape file, I only updated one record here, but you can imagine I can update any of the geometries. I could get rid of the trailing decimal so that I have that. I can insert records into a shape file. I can delete records from a shape file. The other data sources, there aren't too many that I've played with, so you'll have to experiment with them. And one feature I really like is being able to read the OpenStreetMap files without having to load them. So, for example, I took the Raleigh, North Carolina from Metro Extracts. I was able to create a server, link all the tables, query it. I could dump the data into another table. So it kind of beats having to wrangle with command lines to pull data in. And even though it's a spatial foreign data wrapper, it can be used for non-spatial data. So for example, if you're on Windows and you have the ODBC driver, the Access ODBC driver, you can connect to any Access database that you want. You can import a subset of tables. Like for example, here I just linked to all the tables that start with ORD. And yeah, you can see them here. And you could do the same thing with spreadsheets. The spreadsheet part works on Linux as well because it doesn't rely on the ODBC driver to connect to spreadsheets. So you can open up Excel, OpenOffice, if you have the drivers compiled into your GDAL library. And then you can use the other functions in and other extensions in Postgres, like you can use the HStore extension to be able to flip a spreadsheet like this, where they have zones across going on forever, into a row by row where each zone is separate. And you can also do it with CSV files. With CSV, you can specify a specific file, then your foreign server will only load one file, or you could specify a whole folder of CSV files. You just point at the folder, and it's the same thing. Then you have, and it auto guesses what the field names are, so it'll use the header to say that, oh, okay, these are the fields. And I think the newer GDAL can also auto guess the data type by inspecting the CSV file. And my favorite is linking to SQL Server because none of the other foreign data drivers work on Windows. So this one works pretty well. So you just go through you register a system ODBC and then you can connect to it. Okay, I think that's about it. Are there any questions? Uh-huh. Mm-hmm. I can't hear you that well. Oh, I can't even hear what he said. So the OpenStreetMap one? Mm-hmm. Mm-hmm. I haven't done too much querying on QGIS. I mean, like usually the data sets that I deal with are usually just city, so they perform fairly well because I think what GDAL does is it takes the PBF or the OSM. I have better experience with PBF files than OSM files, but I think what it does is it like creates a temporary SQLite database for querying. So usually I use it more for loading data quickly and for inspecting it, like fixing the broken polygons and things and then loading it into a separate table. So I usually don't use it directly that much. And I'm not sure if it can utilize the indexes. I think it can, the spatial indexes that it adds to the SQLite. Yep. Oh, yeah, I'll have a link. Yep.
So using window functions versus going back a few slides where we talked
Oh,
about.
yeah, let me.
Yeah, right here.
Yeah.
What's the trade-off in terms of performance in terms of using window functions to achieve the same sort of bucket numbering? I mean, that looks very much like range or dense range.
Like what?
Like range or dense range using window functions in Postgres?
I think they're pretty efficient. Like in PostGIS 2.2, there's another function that does similar to this. It's like cluster intersecting. And what that does is it puts the things into an array. And the reason why we came up with this is it ends up being faster and more elegant because then you can You can group it however you want. You don't have to do this unnest and then union and all that.
So, but you could do like an ST distance with the window function and then just use range to achieve the same kind of.
Oh, the ST.
The trade-off in performance is doing it this way versus doing it that way.
Oh, doing it with ST distance. I would suspect this is faster, but I haven't compared the two, so I can't absolutely say. But I would suspect it's faster. Yep.
So, I've got a program where I have some rasters.
Mm-hmm.
Put them all in database. And then I'm working out small regions and Instagram small regions.
Mm-hmm.
Is that substantially faster or slower than database?
Before, I always thought the in database was faster, but now I'm noticing that out database seems to be faster because it doesn't seem to have, especially if you have larger rasters that you're clipping, it doesn't seem to suffer from the same penalty that you get because of the way, like the whole toasting thing and detoasting thing. I think it somehow uses GDAL first, so it doesn't have to go through that whole toasting, detoasting process that you have with it in the database. So I would suggest experiment with it because I don't want to say that it's absolutely faster. Yeah. Yeah, the ingest is like immediate. It took me like, for the number that I was experimenting with, I think it would take a couple of hours, whereas this was like 10 seconds. So. Any other questions? Yep. Oh, well, that's a good question. We're hoping that we're going to be done. I keep on pushing the date, but our new objective is to try to get it done this quarter or next quarter. But we have 200 pages written already. So we're estimating that we're going to have 250 pages of PG routing when we're done. It might be a little bit more than that because I don't think we've covered. Yeah, it's going to be both in hard copy and PDF. I think the hard copy is like in color, which is nice because it'll be our first color book. And yeah, the electronic is PDF. Any other questions?